Lesson 21, geotrig, day 3. We only have a few things left to clean up here. Let's just go back and actually recap just a little bit. We talked about domain and range. Domain are the numbers that you put. What? Domain are the numbers that go in. Range are the numbers that come out. Okay? And then we had types of functions. Functions that you will find the domain and range of soon enough. And remember that a relation is just a connection, guys, between the inputs and outputs. So there's a lot of things that we can say that are related. Okay? But it takes a special type of relation to be a function. And to remember to be a function that assigns there's exactly one output for every input. And then we took it one step further. At the very end, we talked about one-to-one function. And a one-to-one function says that there is exactly one input for every one output. That means nobody gets to double up, right? So you can't put more than one thing in to go to the same number out, just like you can't put multiple things on the way out from the same thing that goes in. So it's kind of taking our relations and breaking it down to a smaller and smaller group. Okay? So we're being a little bit more selective. So let's move on to what we're talking about for today is how do I know? How do I know if I'm working with a function? How do I know if I'm working with a one-to-one function? We have tests. So especially if I'm looking at a graph of a function, I can use the vertical line test and I can use the horizontal line test. Now here's the cool thing, guys. If I'm looking at a graph of something, that graph itself is a relationship. Inputs, outputs, x, y, right? So we know it's a relation. But what we need to do is we need to determine, is it a function? Yes or no? And if it is, we're going to take it one step further and say, is it a one-to-one function? And so, to test this, we will graph this function, if it's not already graphed, or if it is graphed, we'll have it. And if it, we'll put the vertical line test to it. So it's a function if a graph in the coordinate plane, represented by the graph of the function, at any line intersects the graph at most once, then it's a function. Vertical line test for functions. It's a function test. In other words, if I had this graph here, and I draw vertical lines. Remember, vertical lines are straight up and down. Yes? If I draw a vertical line, and it only touches the graph once, it's a function. But you can't just do it once. You have to do it again and 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 again. And you have to keep checking everywhere. So, with this one, just by looking at it, pass the vertical line test. Yes or no?
Oh, yes.
Yes, it passes the vertical line test. Let's throw a different graph at you. Piecewise functions, you guys remember those? Piecewise type function, wait, I'm calling it a function already. Does this pass the vertical line test? Let's take a look. I'll change colors for this one. Passing so far?
Yeah.
Passing? Passing? Question. This was fine over here, right? But that line right here somehow poses a question to us. How many times does it touch the graph? I heard 2 and I heard 1. Is this included?
Yeah.
Yes. Is this included?
No.
No. How many times does it touch the graph?
Once.
It only touches once, therefore it is a function.
Wait, why is it
Because this point here is included, but this one down here is open circle, not included.
okay.
So it's not part of the graph, it was an open dot or a closed dot. Okay? So let's try another one. Function? Yes or no? No? Do I need to actually show this? And show this? Or can I just do this and say, look, it hits how many times? 3 times, therefore, not a function. Guys, the definition says that any vertical line touches no more than once, and then it is a function. As soon as I can give a counterexample of it not working, it's not a function. I don't care where else I test it. It doesn't pass once, you're done. Okay? That's like you claiming I'm always right. But as soon as someone finds you doing something wrong once, that statement is no longer valid. I think we've run into situations like that in this class. Now, we have to talk about the other one. The other one is called the horizontal line test. The horizontal line test tests for
Horizontal line.
one-to-one functions. It tests for one-to-one functions. Guys, for it to be a one-to-one function, it needs to be first a function. Okay? If I want to be a purple cat, I first have to be a cat, and then I can be purple. Or vice versa. You have to be both, right? Anyways, what a horizontal line test can say. A function is one-to-one, provided that any horizontal line intersects the graph in only at most one point. Same thinking as the vertical line test, but now we draw a horizontal line straight across. And it can only touch the graph how many times? One time. So, going back to this graph, we said it passed the vertical line test. It was a function.
Not going to be a function.
No, it is a function. The question is, does it pass the
Horizontal?
horizontal line test? So far?
Yes, it's not going.
So far?
No.
So far? No. So therefore, it's a function, not one-to-one. Boom. What is one that does look good? How about this one? Does it pass the vertical line test? Does it pass the horizontal line test? So this is a function, and it's one-to-one. Not so bad, right? Any questions? I think I've got 2 more slides full of examples. Let's check it out. Oh my. Okay. It is a little bit difficult to read, I understand. But the first 2 we have to answer, is this a function? If it is, state the domain, state the range. Now remember, guys, things can be not functions and still have a domain and range. So, looking at the first group, is it a function? Just given that relation right there. Is that relation a function? Yes or no, why?
Yes, it is.
What's the definition of a function again, so we can all understand?
One input for one output.
No, that is 1 to 1.
Shoot. No.
One
Input.
output for every
Input.
input. You said it the other way.
Yeah, I did.
Do we have exactly the same output for every input that goes in? Well, let's check it. You guys are questioning. 17 goes to 15 over 4. That's okay so far. Then if I put 15 over 4, I get a 17. Doesn't matter. That's a different input to a different output, yeah?
Yep.
Then I put 15 in. Can I put 15 to get to a 17 over 4?
Yep.
Then I put 17 over 4 and get a 15.
Yeah.
They're all different inputs. There's no input that repeats itself. Therefore, I would not have to check to make sure it goes to the same output. So therefore,
Yes.
yes, it's a function. What's the domain? AKA, guys, what's the inputs?
17.
I just created a set of numbers we call the domain or my inputs. And the range would be the same thing with the what values. Wise. So no, it's not so bad. You guys all started, you saw a whole bunch of problems and you got really upset that there was going to be a lot of work. But really, is this a lot of work? No. Do the same thing with question 4. Quickly. Yes? No?
No.
No? Why? Yeah, -3 went into 2/5 and 3/5? No, you can't have the same input going to two different outputs. That's a no-go. Domain? -3, 3/2, and 5. I'm not going to double up things, guys. So therefore, I don't need to state -3 twice. What about the range? 2/5, 3/5, -5. Okay? Next one, relations expressed as graphing. So write each of the following as a relation. State the domain and range, then determine if it is a function. Write the following as a relation. AKA, it's a graph. It's a set of points. AKA, ordered pairs. So the first part, guys, is write the ordered pairs, state your domain, your range, and then say, is this a function? Here we go. So we want the relation as a set of ordered pairs. Guys, the biggest thing that you'll have to do when you get something like this, or if you get something like this, is to make sure to watch your scale. It looks like the scale is all going by ones. Can you guys agree with this? I got 1, 2, 3, 4, 5 points. 6. 6 points.
You got a minute there, rookie.
Yeah, you got a minute. Take a seat. So, what are our points, guys?
We have -2, -2. Is that 1?
-1, 1, 0, 1, 1, 3, -2, and 3,
You can write this down.
3. So, once I have my points stated, it's really easy to figure out my domain, isn't it?
Yeah.
My domain, -2, -1, 1, 3. Whoops, that's not a 3 extra 3, it's my bracket. The range, -2, 1, 0. I think that's actually it, isn't it?
Yep.
Function, yes or no?
Yeah.
Ooh,
No.
No. Does not pass the vertical line test right there. Okay? It is, well, we had it listed as a point. Guys, we're going to skip writing the points, domain and range for number 6. Is that a function though?
Yes.
Yes. And is it 1-to-1? Because it passes both horizontal and vertical line tests. For these next couple, we'll talk about, is it a domain, is it a range, what's the domain, the range, and is it a function, and we'll say was it 1-to-1 or not.
Okay, number 1 is not a function.
Number 1's not a function. Let's go through and say, are they functions, yes or no? So, no,
Yes.
yes. Wait, let's stop. If it's a yes, is it also 1-to-1?
Yes.
Okay. So it's 1-to-1. Next one?
Yes.
Yes
But it's not a 1-to-1.
and no, right? So maybe we should say, well, if it's no, then you don't have to check if it's 1-to-1. The bottom circle?
No.
No. 23?
Yes and not a 1-to-1.
Yes and no?
No.
Okay. And?
No.
And no. So we at least all understand how to look at a graph using the vertical and horizontal line test. Now, the one thing I wanted to highlight on this slide is now we're not talking about particular, spit it out, right? Particular values for a domain and range. We now have to have a range of values for both domain and range. So, if I'm looking at my domain, guys, the domain of 19 starts at, what's that value right here? Looks like -2 and goes this way.
Yeah.
Wait, didn't we do set notation and interval notation? What's the interval notation for this?
Oh, couldn't you do
-2,
-2?
comma, infinity. -2 has a bracket and then a parentheses.
Oh, that's so much nicer.
What about the range? Range goes up for ever and it goes down forever. So therefore, parentheses, -infinity to +infinity, parentheses.
Oh, that's how we state the function in range or the range.
It's interval notation, yes.
Oh, that's so much nicer.
Now, for 20, I would even make it even easier. The domain and both the range are from -infinity to +infinity, right?
Yeah.
Can't I just say all real? There's multiple ways to state these types of things. Now, I'm not going to write these down. We're just going to talk about them. 21 real quick. What's the domain? Looking left. Looking left.
Right.
Going on forever. Going to the right forever. X's are all real. The range goes from -1 to 1. Actually, let's write this one out. That would be -1, comma 1
Oh, yeah.
with brackets. Homework for lesson 21 is page 158, 3:16 through 20. Have a great day.